I started actually my career in space industry with traditional satellites. So my babies there were Cassini-Huygens and Rosetta. So these were spacecraft, interplanetary spacecraft with several tons of mass. And from Airbus in industry, I was inspired by Bob Twiggs when I was in Stanford, teaching about interplanetary spacecraft. And here I got also a call to come to Würzburg. And my first activity was then in Würzburg to build CubeSats myself with the help of Bob Twiggs. And this inspired the students a lot. So this was the first German, the second European CubeSat, which was launched. And in fact, it was launched together with XI5 from University of Tokyo. So here also the door opened for broad international cooperation, which was great. And so step by step, the UWE educational satellites provided all the capabilities to fly in a formation. Next slide, please. So this complexity to use multi-satellite systems is an advantage of the CubeSats. As they are not so expensive as the traditional satellites, we can practice cooperation in space, satellite systems. And here in the Center for Telematics, we had the opportunity to increase the complexity towards multi-satellite systems. Yeah, and here are full-time employees, not students carrying on, but students are included. So this was launched in 2020 to demonstrate self-organization, new measurement principle with CubeSats in orbit. Now, last point I want to make, when we want to place multi-satellite systems in space, we need to produce multi-satellites in a short time frame. So what we are currently working at is production of small satellites in a small series. And here we apply Industry 4.0 methods. Now, again, in an industrial context. So meanwhile, I left university and I work in industry. And we have robots involved, automation system to produce constellations and formations of satellites to further innovate sensor networks in orbit. Yeah, so it's a whole life cycle from industry via academia back to industry. Thank you.